Welcome back, campers. We are on day 2 of Botanist Lab, and day 2 is technology, right? So, what is technology? It's a great question. Do you know what technology is?
Computers?
They are a form of technology. It's true.
You
have any other ideas?
TVs.
Maybe.
Technology.
What is TVs? They employ technology. It's true.
Yeah.
So here's a definition of technology.
It is.
Can you read that?
Thing that
it's the practical application of knowledge, especially in a particular area. It is a capability given by the practical application of knowledge. Capability, so you're able to do something, and it's a manner of accomplishing a task. Now, if you were with us for the archaeologist lab, we talked about technology and how ancient technology could have been something as simple as like simple tools that the earliest of humans used. That was still technology. Like a what?
A stick and a piece of metal for an axe.
It's true. Or maybe a stone.
A stone and a stone for later. Kaboom. Kaboom. Chig.
It's true, though. It's true. So technology gives us capabilities. It's an application of something that people already know. So when you apply that to plants, plants plus technology actually equal awesome, right? Here, I'm covering this one. I'm so sorry. Let me move down here. So you can see there's some really cool things that happens when you mix plants and technology. There's something called nitrocellulose and other nitrated plant polysaccharides that create plastics that are compostable and don't require fossil fuels. So you can see these plant products up here, cups and different kinds of plastics or ink, and those are really good for the environment. Also, there is something called nitrocellulose or gun cotton. There was a scientist who spilled chemicals in his kitchen.
And
he was doing an experiment.
His apron to clean it up.
How did you know that?
The book. And then, but the thing exploded.
It's true. He thought he washed it and it all came out fine, and then the apron exploded. That's fascinating. I guess librarians' children read a lot or something. That's amazing. There's also something called phytoremediation. That's how plants use and cycle water through their systems. And botanists and scientists have found different ways of filtering pollution through plants or creating plants to be better at filtering pollution to help the environment. I'm just going to move up and over the gun cotton for a minute. Down here at the bottom, you can see that scientists have also created bioluminescent plants by splicing DNA from things like bioluminescent algae or mushrooms, or even some bioluminescent animals, and by creaing
fishies.
Well, some fish, yes, exactly.
Or jellyfish.
For instance, and so
or the little floaty stuff, floating around, blob, blob, blob.
Algae, phytoplankton, things like that.
No, I meant like this floating goo, like.
But it has a name. It's not just goo.
I mean like if a bioluminescent animal dies and it gets eaten, if it chomp in the goo that makes it bioluminescent squirts out and just floats around.
Is that true?
Maybe.
I'm going to be a resource on that.
Maybe.
Me
not know, but that could be possible.
Anything could be possible. So, botanists and scientists have created bioluminescent plants and alternatives for meat. Have you seen those knot burgers? They look like hamburgers, and they're not. They cook up like them, but scientists have to figure out ways that plant products mimic meat products. So for instance, you have to find a fat that binds the vegetable material that at room temperature or below, it is a solid. However, when it's cooked, it becomes liquid. So they use a lot of coconut oil, for instance, to make those. And the red color and this is interesting, the red color and the extra iron that comes into that knot burger actually comes from yeast that's grown in a vat of red yeast food. Actually, yeast, ambient yeast, little bits of living material. Not quite a plant, right? So
not quite a plant.
Plants plus technology. Awesome, right? Now, there are all sorts of tools. Let me move just a second here, sorry, that botanists use. And we talked about this a little bit in the introduction. But you can see here, there are different kinds of technology that botanists use. From very simple things like tweezers. And this here in the middle, this person leaning down, that's a plant press. So what happens is when you're out in the field, you gather specimens and then you press them in between either pieces of paper or cardboard so that they're preserved, right? And then you're getting down to splicing DNA and extracting DNA and investigating things at a cellular level. You're going to need some pretty high-tech equipment like microscopes and petri dishes and things like that that you would use in a laboratory as well.
Or it does need a lot of magnifying glasses. Like stack them on top of each other. No.
Sounds like an experiment for another day, doesn't it? I think so. Now, I would like you to meet another scientist. This is Dr. Virginia Murray. She is a toxology and global public health crisis expert, right?
What
so she lives in
toxology?
The toxicness of plants,
Ooh.
right? So she knows all about poisonous plants and how they act and interact with humans.
Like some nightshades.
What happened? Ooh.
Like some nightshades.
Yes, like some nightshades. But the thing that's really interesting, not only does she know all about poisonous plants, but how they interact with entire countries. Like a public health expert is somebody that knows about the health of communities, right? Whatever size that is. So she works for the United Nations and investigates how plants interact with great big communities or even small communities and how to keep people safe.
Like Mount Vernon.
For instance, yeah.
Mount Vernon is small.
It is, you're right.
And we live in Mount Vernon.
Also true. You're finding out so much about the Crawfords today. It's true. So, how about day 2? Get your bags out. Let's unpack. I forget what's in day 2. I remember now. You have glow-in-the-dark beads. So glow-in-the-dark beads, not only because we talked about bioluminescence, but we talked a little bit about nanoscience, right? The science of, do you know what nanoscience is?
Yeah.
What is it?
The science of teeny, tiny, tiny things.
It's true. You're right. So the nanoscience is actually used in making glow-in-the-dark beads because those glow-in-the-dark pieces, the chemicals that make things glow-in-the-dark are so very small, right? Oh gosh, I'm over the words. So it says project, experience the glow, right? So this is a little bit science and a lot more art. So things to think about. Genetics are amazing. Genetics are what make up the blueprint, pretty much.
Yeah.
For
if like
living things.
Blue, blue, blah, blah, boop, bop, bop, then maybe she will be like,
my ears might be bigger. My chin a different shape.
Well,
Or, so for instance, this is my child, right? Do we look alike? Baby pictures of this guy and me look just alike. He looks more like his dad the older he gets. But when I was his age, my hair was this blonde, right? He gets that from me. That's part of your genetic makeup. Light eyes, blue eyes, come from dad's blue eyes and mom's green eyes, right? Green. I think you have to be over here. There. Show the folks at home those baby blues, right? So genetics determine how big or how tall people are, but also genetics work in living things too. All living things. So plants have genetics.
Like pants.
Pole ants, not pants. I don't think pants have genetics.
Yeah.
But so
Yeah.
plants can have their own environmental genetic variants, but here's a shameless plug for the podcast Wow in the World. If you don't listen to Wow in the World, it's incredible. Please don't. That's not necessary. But this guy was just giving me some facts from Wow in the World. Please don't. But here's something important. So genetics can vary in the wild, but also humans can modify things like the bioluminescence, right? Or making plants drought resistant or insect resistant. But here's a good question. Is it a good idea to modify genetics? What could go wrong?
They could turn a plant into a giant hungry animal that wants to eat humans.
Well, I suppose that is a possibility.
Yeah.
But it's a good question. How much should people mess around with the genetic makeup of animals or plants? So that's something to think about. And here's something else to think about. There are all sorts of new species that are yet to be discovered. So there could be some actual bioluminescent plants that no one's ever discovered yet. That could be you. So until then, here's your project. You should have an elastic band and a bunch of glow-in-the-dark beads. No, you don't. I'm sorry.
And fine.
But if you string the beads onto your elastic, you can create loops and twist to make patterns that look like flowers, or you can just, wrap it around for a bracelet or a necklace. But you can create shapes and your own bioluminescent flower by doing that. So that project brings us to the end of day 2. Don't forget to check on your seeds, right? And keep making observations about the plant life in and around your house or somebody else's, or go for a walk. Or there's so many natural areas around. You don't have to get close to anybody to go check out some plants. It's true, in your backyard. Thanks for joining us.